Okay, so for this problem, it's asking us a body of height 40 centimeters and a uniform cross-sectional area floats in water. 10 cm of the height of the body remains above the water line. Okay, and this diagram shows us that setup. The density of the water is rho. Okay, so I can denote that with rho over there. And then the question is asking, what is the density of the body? So in other words, it's basically asking us to find the density of the body here, okay, on top, above the water line. So how are we going to approach this problem? Well, first of all, it would be helpful if I just simplify this situation by drawing a free body diagram, if you will, okay? So this body is going to be represented by a dot. Okay, and notice that you have water, you have a part of the object submerged in water. So you're actually going to be analyzing the vertical forces acting on this body over here. Okay, now first things first, notice that the question talks about cross-sectional area. Okay, so if you have an object like this, you can actually kind of extend it or like draw like as such. All right, so you realize what that cross-sectional area is, or you have an idea at least, because whenever we say cross-sectional area, this refers to the shape that you get, the area of the shape, such that when you slice your 3D object, okay, what shape do you get when you slice it in the middle? Okay, you get the area of that shape. But anyway, in here, okay, since we're talking about cross-sectional area, if I kind of extend it like this, the area will be this part over here, represented by A. All right, well, now what is the force that's putting or pulling, okay, this object down? All right, well, we know that that's weight. However, how do I relate density, area, and in this case even the length of the object, so that I have it in terms of density? Okay, well, please recall that weight is actually equal to your density times volume. All right, so the weight, which is the force that's going down here, is actually equal to density times volume. So if I want to get the weight of this entire object, okay, first, okay, I will have to get the certain density for that. All right, so that's going to be density of the body. Okay, now the question is, what is V going to be? Well, how do I relate V and area, volume and area? The general formula for volume is area times height. So if I'm looking at this entire object, the area here, okay, so instead of writing V, I'll just say area times the height, okay? And how tall is this box? Well, 10 plus 30, that's equal to 40. So I can actually just write that as 40A, but I'll leave it like this for now. Okay, so this is an expression here, density of the body times the volume of the body, which is just the same as 40 times the cross-sectional area A. That contributes to the weight of my body. All right, now that's the force, the downward force. But what about the upward force? The upward force is called our buoyancy force, if you remember, our force of buoyancy. Okay, and buoyancy is defined to be the volume displaced by the object. All right, so to write an expression for the force of buoyancy, okay, I'll tell you right now that this is going to be the density, all right, the density of the water in this case, multiplied by the volume of a particular area that got displaced. But I'll write 30A. Now the question is, why is it 30 and why is it not 10? Okay, for the force of buoyancy. And that's because, again, going back to the definition, this object, okay, 30 centimeters of the object got inserted in the water. Okay, so it's like 30 cm of water got displaced, if you will, right? Because again, buoyancy refers to the volume that got displaced. Hence, okay, because 30 cm of the object was inserted, I am going to account to that 30 cm when I'm substituting values for the volume aspect of my formula. Okay, so just to be clear right now, the expression I have for weight is density times 40A. Okay, this is my volume of the entire object. And then my buoyancy force is density times 30A, which is again my volume for this particular part that's submerged. Okay, so at this point forward, I'm just going to set them equal to each other. So that's going to be density multiplied by 30A, okay, equals density of the body, okay, multiplied by 40A. Okay, now at this point, okay, I can just isolate what I need to solve. The question is asking us, what is the density of the body? In other words, what is an expression for P of B, right? B for the body. Well, isolate things. So I'll have P 30A over 40A. Okay, A's cancel. This can simplify to 3 over 4. And so my answer is 3 over 4 rho. And that is indeed letter D.